A system of nonlinear equations can be sometimes solved using elimination method. This is possible only when one variable appears in the same form in both equations. If we look at our equation, you can see that the variable x appears as x squared in the first equation and as x squared in the second equation, and there is no other term that contains the variable x. Therefore, variable x can be quickly eliminated by multiplying the first equation by -3. If we multiply the first equation by -3, that equation is -3x squared plus negative minus 9y squared is equal -15. And the second equation remains the same, 3x squared minus y squared is equal 5. The coefficients of x squared are opposite numbers, therefore if we add those two equations, the x squared terms are going to be eliminated and we are left with just -10y squared is equal -10. That means that y squared is equal 1, and that means that y is equal plus or minus square root of 1, which is 1. Now for each value of y, we'll find value of x that will solve the equation. So if y is equal 1, we'll use, let's say, the equation 1 to find the value of x. The equation 1 was x squared plus 3 times 1 squared is going to be 5. So that means that x squared is going to be 2. And solving this equation gives us plus or minus square root of 2. And therefore the solutions that correspond to y equal 1 are square root of 2 and 1. And the second pair is negative square root of 2 and 1. The second value of y is y equals -1, and if we use again the first equation, we'll have x squared plus 3 times -1 squared is equal 5, but since -1 squared is 1, we'll get the same equation as in the first case, eventually leading to the solutions x equals plus or minus square root of 2. And therefore the solutions that correspond to y equal -1 are square root of 2 -1 and negative square root of 2 -1. Therefore this system has 4 solutions.